Is it on? Now it's on. Good morning. Hey, that's not too bad. All right, good morning. My name is Anna Latney. I'm a CropWise digital product manager at Syngenta, and we have been so pleased to be part of this event. Thank you all. I want to thank Danny and the organizing committee before we go too much further this morning for all of the hard work that they put in so we could be here together. So let's give them a quick round of applause. And I have the pleasure of introducing my colleague, Dr. Zach Marston. He has a background in plant sciences and agronomy, but for the past 10 years has dedicated his career to applying computer science to improving outcomes in digital agriculture. He is currently the product manager for CropWise AI, and is going to bring the story to us about how AI is coming to our whole family of digital apps called CropWise. So thank you.
Thanks, Anna, and thank you, Danny, once again. I'm not sure where you ran to for inviting us here. Thanks to everyone who's able to attend today and listen to some of the journey that we've been going through to bring AI into CropWise. So, let's see. There we go. So as Anna mentioned, I've got a background in applied plant sciences, entomology, plant pathology, but I've spent more of my time focused on some of the computer science things, taking agronomy, digitizing it, building computational models, and ultimately deploying them so growers can use them. Over the past 3 years, I've really been focused on our flagship product, CropWise AI, which is trying to bring all of these things together with large language models and generative AI in order to sort of change the way that we're doing things. And so today, what I really want to talk about is some of the journeys that we've gone through. I want to share a few stories and talk about some of the challenges that we've had along the way of actually making AI productionized and usable by growers. And I think this is something that a lot of you may be encountering now, you may be encountering soon, but ultimately some of these stories are going to be pretty helpful. So I wanted to start with a couple reports from Gartner. And I'm not sure if you guys have seen these numbers before, but right now they're saying between 50 and 85% of AI projects fail to deliver any sort of value. And there have been various reasons for that. About a year ago, the number one reason was data quality, which is still up there. But more recently, the number one cause is a lack of business value. And I don't disagree with this, but I think that one of the big things that most people don't talk about with regards to Gen AI right now is that the learning curve is so much steeper than some of the traditional models that we've been building with machine learning, where you can do cross-validation, you can use reliable processes that have really been tried over and over again and have been proven. And so ultimately, whether it's ownership cost, responsible AI development, change management, there are a number of reasons that AI projects fail to deliver value. But what I want to talk to you about today is what I call the visibility gap. And I'll explain this in more detail as I go through this project, or through this talk. But ultimately, the visibility gap is something that I think a lot of us face when it comes to Gen AI, because quite a few of these solutions are still black boxes. But that's not the only visibility gap that we face, and I'll talk a little bit more about some of the other visibility gaps that we really go through as we're trying to productionize these products. So before I go into the journey, I want to do a little character development for those of you who may not be aware of what CropWise is, or what we're doing with it today. So in about 2015, Syngenta started to recognize the value of digital agriculture and how some of these farm management products could actually be useful, not only for growers, but extension, agronomists, retail. And so they started acquiring a number of different digital companies, Strider from Brazil, Crop.io over in Ukraine. There are a few here in the US. And in 2020, we rebranded all of these as CropWise. And since then, we've been developing these applications, and we're now at a point where we have over 16 digital applications that help people throughout the growing season. And not only are we, integrating these capabilities with Syngenta data and grower data, we've actually integrated with, John Deere Operations Center, other, farm systems, farm machinery. We've got weather, we've got satellites, and more. But we have been deploying AI solutions within these for quite a while. And this is not necessarily Gen AI solutions. Most of these are more traditional crop models, things like phenology or yield prediction or disease models. But ultimately, these are all intended to help with decision support. And when you put all these things together in these connected apps and you deploy them into different farm scenarios, what we're seeing is that these can help bring people together to solve some of the agronomic problems that they're facing every day. Whether it's just visibility into what's going on in the field through recording scouting observations or using things like CropWise imagery for anomaly detections in the field. It's kind of a system that's helping keep everyone together so that they can make sure that they're more productive year over year. Because of what we've put together in CropWise, we've actually seen CropWise grow to a point where we were at, I think the number is now 76 million hectares as of yesterday. We're active on over 76 million. These are 76 million different opportunities to learn every single season. And on top of that, we've hit over 85,000 users that are distributed across 30 countries. So we have a really good idea of what's going on in terms of agriculture, but not just in one location, because people do things in many different ways in many different regions. And ultimately, we're capturing that variability every day. About 3 years ago, we tried to start bringing CropWise AI together by pulling from Gen AI and trying to inject it into CropWise to make it wiser. And this has been quite the journey. And really what I want to do is share some of the learnings that we've had. And so about 3 years ago, we started with 3 simple use cases where we wanted to see if we could actually leverage Gen AI to answer some simple questions. And at the time, there were really only 2 approaches that people were taking. One was sort of the closed book exam of using foundation models that have been fine-tuned. And foundation models on their own don't have your proprietary data. If you've published things on the internet, there's a fair chance there's some of that in there. But these models on their own have not been designed specifically for agronomy. And so at the time, 3 years ago, fine-tuning was one approach that people were taking to try and make these models work better for agriculture and for the problems that they were having. But ultimately, fine-tuning was pretty complex. There weren't a lot of platforms that enabled an easy way of doing this. And so the other option was retrieval augmented generation, or RAG. And this is where you could build a knowledge base of your documents and ultimately leverage that to ground the answers that your large language model is giving in your own proprietary documents. And so you can think of this as the open book exam. And ultimately, we decided to go with RAG because it was faster and easier to iterate on. And so for our first attempt, we put together 3 different use cases. And we tried to get some variability in what these use cases were. We started with what we thought was the easiest solution, just digital support. Can we answer basic digital product support questions based on our technical documentation around our products? These are things like, how do I reset my password? And ultimately, there is a specific series of steps. It's a recipe to get there. And this was tested by subject matter experts who handle these types of questions every day. It was our digital support team in Murray, Kentucky. We also had a general agronomy use case where we were trying to leverage what we call our Golden Harvest Agronomy SharePoint site in order to answer questions that pertain to general agronomy. Think, how do I manage white mold? And then our final one was really focused on our herbicide portfolio. And the nice thing about our herbicide portfolio is that it really combines the complexity of the 2 different use cases, where with digital product, we have that specific recipe. But if you go to general agronomy and talk to an agronomist and ask them a question, 90% of the time they're going to start with, well, it depends, right? And this is something that's kind of hard to capture when you're using a large language model because they're trained not to do that. They're trained to give you an answer. And so the herbicide portfolio was the ultimate test because we had the combination of it depends with a legally regulated label that we have to, follow in order to be complicit. And so as we started testing, we actually ran through 3 iterations of each test with each group. And we started with a set of 30 curated questions that we knew we needed to be able to answer adequately in order to really make these valuable. And so for our digital product support, after 3 iterations, we actually came out with 90% accuracy. We're feeling really good about this. But the problem was when you talk to the team that was testing this, they said, yeah, I don't really want to use it. And the question that I was asking was, well, why? And what we found out was that these questions were so simple that a Google search was actually returning the results faster than our system was at the time. And even when they could find the information on Google, their preference was truly to talk to their neighbor who probably already knew. And so this is some of the change management that people are going to face. Just because you're hitting high accuracy marks doesn't necessarily mean that you've hit the value that you're trying to achieve. So at General Agronomy, we went through the same 3 iterations and we came out at 74%. Now, the challenge with 74% accuracy on general agronomy questions means that 1 out of 4 times you're going to be giving bad advice. And so ultimately here, 74% isn't close to good enough. And you can talk to our legal team, you can talk to people in the industry, and you can say, well, what's good enough, right? What accuracy do I actually need to achieve to have something that's valuable? And quite frankly, no one will give you an answer. And if they do, don't trust it. So then we moved on to our herbicide portfolio, and this was pretty devastating, actually. We only hit 66% accuracy here. And after 3 iterations, you would think that we would be able to climb above 66% accuracy. And this was back in the days of ChatGPT 3.0. So things have gotten massively more intelligent, about 64 times more intelligent if you count for doubling of the intelligence of these large language models every 6 months. But the real heartache here was that even though we continued to iterate and technology has gotten better, only giving 33% incorrect answers was really dangerous, because not only was the system confidently citing our information, it was actually citing the information and still drawing the wrong conclusion. And so this could mean herbicides that kill an entire crop. It could mean harming someone, endangering livestock. It was pretty serious. It felt like we were giving the system an open book exam and it still failed it. So we really had to think hard and long about how we were going to pursue, moving this forward. And shortly after, once we realized some of the major risks of this technology, Syngenta put some of its, best minds together to come up with our AI manifesto. And this is what we're using to really focus on deploying AI ethically and responsibly into the public. And don't worry, you don't have to memorize this. This won't be on the test. But ultimately, if you want to look more into this, we have a website that's posted the entire AI manifesto, and I recommend giving it a read. Because some of these guidelines are guidelines that should be embraced by everyone, and we're seeing many in the market right now skip quite a few of these steps. So I won't go too far into detail about this, because I think the rest of the story is a little bit more entertaining, but we had to go back to the drawing board. It was pretty clear that with herbicides, we weren't there with the technology. We needed to restructure what we were going to do. So there was one thing that came out of that general agronomic advice that was really important. And we heard this both from an agronomy team that was testing and from our technical services team that was testing. But I was in Minnesota a couple weeks back, and I was talking with a retailer, and I think he said it best. He said that AI is still giving advice that sounds like the advice you'd get from a friend of a friend that knew you had a farm. And quite frankly, I resonate with this a lot, because most AI is not specific enough. It's not asking follow-up questions to really understand what's going on in your situation. So we knew that we had an excellent computational agronomy model that could actually do seed selection for specific parcels of land. This is a seed recommendation that's tailored to your environment, your field. It's ultimately made based on science that we've proven over and over again. It's a deterministic model, so you're going to get the same response every time you run it. And we wanted to combine that with our seed product information. And so ultimately, we knew that it would be difficult for people to verify a seed recommendation because they don't have access to the model. They don't have access to the data. So in order to make people trust the seed recommendations that we were giving, we would have to get the basic information right first. This is just our seed product information. There are a number of different variables that we have in our seed products, ranging from relative maturity to disease ratings, and we had to tell the large language model how to interpret all of these things. We had to tell it what a 3 on a tar spot rating actually means. But we knew that if we couldn't earn trust in those basic things, we would never get the opportunity to actually recommend an action, which is, plant this seed in your field. It'll do well. So we put this together, and ultimately we knew that we also had to make a transition to agentic AI. And so I think a lot of people in this room at this point understand what agentic AI is, but at the core of things, this is a model that can reason and it can select tools and use them to generate a response that's grounded in something other than its own information. So we put together this agent, we started testing, and we were building our first agent. We knew that we had to earn trust, but we had a lot of lessons from that first pilot that we ran. And so we were able to build this simple agent that would get the question, it would interpret it, select a tool, and ultimately call some sort of API and generate a response. And we were able to move through this pretty quickly. We had built, a set of ground truth questions that were really basic at the time, but we tested the solution, we hit over 90% accuracy, and we felt like this was a pretty big breakthrough. So we started working with the AWS Gen AI Innovation Center because we were getting ready to scale this into production. And during that time, we had to make a switch as we moved from, the code stack that we were in onto the AWS Bedrock platform. And at the time, we had to make a switch on our model from GPT 3.5 to Claude's Haiku 3.0. And this was back when Claude was really starting to be raved about. Haiku was smart, it was fast, it was efficient, it was capable of doing all of the things that we were doing with ChatGPT 3.5. And we honestly felt like this was going to be an improvement in the accuracy that we were getting. We thought we'd go from maybe 90% to 94%. We thought it would get better. But what we found out was that every single model has its own personality traits, its own quirks. And ultimately, you have to optimize the process that you're using for the specific model that's, running the analysis or querying the tool. And so what we ended up seeing was the exact opposite of what we expected. We saw a decrease in accuracy. And it was really difficult to figure out why. So we started pouring through these, CloudWatch logs that have the interaction between the agent and the tool to figure out if we could determine where there were problems. And ultimately, it was really difficult. We were manually pouring through this information. It was taking hours and hours and hours, and we knew that there needed to be a better way. We needed to find a way to see inside what was happening and go from this black box solution to a glass box where really we had visibility into every single interaction. Because we were testing things, but we would ask the same question, and then we'd ask it again, and we'd get a different answer. And we'd ask it again, and get a different answer. And so ultimately, we were inconsistent. It was unexplainable why we were inconsistent, and it was unacceptable for us to move forward. So we had to really think about how we were testing, and we had to build something that really wasn't available in the industry at the time. So we had to borrow some principles from the software engineering world. There's been a transition over time where software developers used to be called developers or coders. And now we largely refer to the profession as software engineering. And I'm sure many of you heard of vibe coding, and there is a difference. But ultimately, about 60 or so years ago, there was a software crisis. There's a NATO conference where the term software engineering was coined. And the difference is, instead of manually debugging things, all of a sudden software tests became a thing. And over time, we started to develop things like integration tests, regression tests, and unit tests in order to validate that our code was doing what it was supposed to do, where it was doing it. And so if you change things in one area, we made sure that it wasn't interfering with something in a different area. Well, it took 60 years for the software development community to go from, just this general basic capability to what are called CI/CD processes, or continuous improvement, continuous development. This is where we're using these software tests to ensure that we're confirming that everything is working properly before it's deployed. Now, some of you may have heard of this Claude leak a few days ago where, maybe they didn't follow these processes properly. There's manual intervention to make sure that even though you've got these CI/CD processes in place, humans are doing checking on the code. So I wanted to know how we could borrow some of these principles to really dig deeper into what the AI was doing when it was actually answering a question. And we came up with a much more robust evaluation system than was on the market at the time. We spent a lot of money and energy, tons of effort, pushing forward towards a better evaluation subset so that we could truly test the inner workings of our entire system. And so we tried to build evaluations that would test intent. Did the agent actually understand what the user was asking? And then did it select the right tool? Was it able to identify that they were asking a seed product question and not for a seed recommendation? Did the tool actually make the right query? And when it made that query, did it get the right information it was looking for? And finally, the response. Did the agent interpret that information correctly and give it back to the user in a way that it was not only accurate, but customer ready, ready to be presented to the world, something that they could easily understand. And so we started to build this golden test of test questions, and ultimately, we felt like we were back on track. Now, all of a sudden, we had the visibility into the solution that we needed. We were able to use Claude 3 Haiku and move forward towards 90% accuracy again. And at this point, I was really excited. I remember sitting there this day, sometimes developing these things is a roller coaster of emotions. There's highs, lows. This was a definite high. I was eager for the stakeholders to start testing this. I couldn't wait for them to tell us how smart we were. I really thought that we were onto something. The problem is they didn't. So the next morning, I got a message on Teams. And one of our stakeholders had reached out and he said, Zach, this is still terrible. You're not even answering basic seed product questions accurately. And I put my head down on my desk. I wanted to go to the bar, grab a beer. We had put a ton of effort into this. I didn't want to continue working on it. I just wanted to put my computer down and walk out for the day. But that wasn't an option. I decided to start going through the logs in CloudWatch yet again to figure out what happened here. And it hit me right in the face. He asked the question, tell me about hybrid G11. Now, I don't assume that all of you are incredibly familiar with our Golden Harvest seed portfolio, but we don't have a hybrid called G11. There's a hybrid called G11 V76, which is what he was referring to. And there's only one hybrid that starts with G11. So for him, this question made total sense. It was something that ultimately we should have gotten right, and he expected us to get it right. And this is the reality. The reality is that farmers take shortcuts. They're not going to type out a question the way that you expect them to. I'm embarrassed to tell you about some of the questions I've actually seen come into our system, and people expect it to work. And we're not going to get everything right. We never will. We're not aiming for 100%. But where there's a clear expectation that this would work and we're missing it, we have to rethink what we're doing. And so that's when we realized we were still really building for the lab. We're not yet building for reality. Reality is far messier than what we were trying to accomplish. So we had to go back to the drawing board yet again and start building a test set that would actually work in the field. And what this truly meant was that we needed real user queries. We couldn't rely on what we were doing alone. So we continued to ask for people to put together these ground truth questions, and you'd be surprised at how much friction there is in that process. People don't want to spend time imagining a bunch of questions they would ask AI. They would much rather just test something and have it work. And so what we tried to do is we tried integrating a feedback module. And this would allow people to flag responses that they thought they were inaccurate. But there are a couple challenges with this. And the first one is if you're not testing with the subject matter expert, well, how do you know if the question's right or wrong, or the answer is right or wrong? On top of that, ultimately, none of us Google anything that we already know the answer to unless you're just trying to prove how smart you are to your friends, and then you don't need AI to help. But the biggest challenge is that people don't give feedback. I can't tell you how many times people have gotten a great answer and just never clicked the thumbs up. And in order to get a thumbs down, you almost have to insult someone's parents, insult their mom. But what we saw was that we were able to get feedback once we started instructing our users how to use this and why it was important, and that we needed their real questions and where the performance breaks were so that we could ultimately get to a better response. On top of that, what we noticed is that people were starting to use the product more and more. And as this happened, conversations were going longer. And as conversations get longer, something that happens is the context that they've actually created within the model can now start poisoning future responses. And so it's not enough to just do a quick test where you test from end to end, restart the agent, ask another question, test end to end. We had to really think about what we were doing and how we could test this so that it was similar to what a real user would experience out in the field. So we started on building a more reliable framework for testing. And this is something I'm calling the field readiness framework, but ultimately it goes above and beyond what I've seen in the industry so far. And this is the secret sauce. This is the biggest difference maker in testing AI to prove field readiness. It's not enough to do the simple accuracy. One question, one answer, you report your results. Ultimately, asking the same question 5 times can get you to 5 different answers. So how do you ensure things are repeatable? How do you measure the standard deviation between responses to understand that what you think is going to happen in the field is actually what people are seeing? On top of that, we need robustness. We already saw, we were expecting the question, tell me about hybrid G11 V76. Well, we have to paraphrase what the user is asking. We need to test for robustness. We need to ask it at least 5 different times in 5 different ways. And finally, we needed to look at resilience. Now, resilience is important because most interactions with AI are multi-turn. And so it's not enough to just ask the one question and get a response. You need to preload 4 questions, and you should do it randomly, and then test the 5th. And what this gets you to is an understanding of whether the previous context is going to interfere with the response that you're getting. And the final and most important one is probably latency, because ultimately 15 seconds in a digital application can feel like an eternity. And so if we're not fast, it doesn't matter if we're accurate, people just won't use it. Well, the secret's out. This was the visibility gap that we had. We weren't testing things for the field, we were still testing for a lab, and we had to get to a point where we were actually testing things for the field. It wasn't that we had bad data, it was just that our test didn't anticipate what the user would actually experience. And so starting to transition this, we focused much more on getting some of our evaluation questions up front before we even start working on a new capability within AI. And I think this is really important because it helps us to understand what's going to be asked. And this is still difficult to this day. A lot of us are using, Gen AI to come up with these questions. And ultimately, that's a totally suitable way to do it. We just have to make sure that those questions are what users are actually going to experience. And the rest of the AI community is starting to come along to this, but the biggest challenge is closing this visibility gap. And so we saw early on that we had a pretty big gap when we released things. We were testing at 90% accuracy, but our users were saying, maybe you're 50% accurate. By using this evaluation module, we were able to close that gap a little bit. With field readiness, we were able to get much closer. And just a couple weeks back, Serge over here was able to test one of our newest capabilities focused on CP product recommendations. And we ended up with a 98.4% accuracy on our tests and 94% accuracy based on user feedback. So we're truly closing that visibility gap. We can see into what's happening, and as we're closing this gap, we're getting closer and closer to what user expectations are really focused on. And, we're not the only ones who have been paying attention to this. This is a big deal, even right now, in the AI community. AWS, who had been working on Agent Core for a while, released their evaluations, last year, but even most recently, they've had another release going to general availability where they've got these 13 built-in evaluators. OpenAI recently acquired PromptFu. This was, yet again, another way to evaluate what's actually happening within the models. Databricks acquired Quotient AI. LM Arena just got valued at $1.7 billion. So ultimately, people understand how important evaluation is, but not all evaluations are created equal. And so we really have to make sure that we're focusing on how we evaluate things, not just what we're evaluating. And I think that what you'll find is that people who invest in evaluation infrastructure will be the ones, the 15% that make it. Those who are not are going to be the 85% that still fail to deliver value. So the big question is, with all this information, where are we today? And we've already deployed a number of large language model-based applications or Gen AI-based features within our CropWise platform. The primary use cases so far have not had that infinity box of the open chat. And so because they're a little bit closed off, these are a little bit more simple, but they're valuable nonetheless. Starting with things like data summarization or voice-based input or planning and data classification, we've already seen 24% of our active users adopt these AI report summaries. And they're not just signing up for it, they're clicking on them too, over 14,000 in the past 6 months. 70% of our users that are registering sprays are now using our AI pest targets in order to make the process a little bit easier. But there's quite a bit more on the horizon. And we're continuing to build this out, and this is our true agentic infrastructure that's going to be able to handle those complicated questions that people are getting out in the field. We started with seed product information. We've now gotten to a point where we've added agronomic decision support. We've got field intelligence so that we can personalize responses so it doesn't sound like it's coming from a friend of a friend that knew you had a farm. We've got targeted seed recommendations. We've made that integration work, and we've, now at a point where it's integrated in 2 different countries. And we're trying to expand this globally. More recently, we've been working on these CP product recommendations. We're not done yet. Most of these capabilities are only released internally as a beta to try and make sure that we're truly getting enough robust testing to deploy them and have faith that they're gonna work. But what we have done is, with our evaluation module, we've been able to switch models now, multiple times, because most of the models that we were using have been either decommissioned or delisted off Amazon Bedrock, and we've been able to continue keeping our accuracy high because we can truly see through things. And this makes a huge difference, because ultimately what we've been working on is the core of CropWise AI. And this starts with accurate seed and CP information so that people can truly leverage our products to improve their outcomes. But it really gets enhanced when we start using CropWise data to personalize it and using deterministic computational agronomy models that will generate a better recommendation than AI will on its own without, overloading context within the large language model. And this is incredibly important, because if we're not accurate in the core, everything that we do that cascades out from that core is prone to errors. Those can compound, and you can result with problematic recommendations. You can, have answers that don't make sense when you start to put these into more robust workflows. And ultimately, we've all talked about this, but trust is essential. If you can't earn trust, you don't earn the right to start making those recommendations. No one's gonna take an action, and you can't even help them with execution. And so what I've showed you so far has been predominantly reactive, right? People opening a text prompt and asking a question, but this isn't the future. This is where we're at right now, today. People can do this. They can go into ChatGPT. They can, use Gemini or Claude. It doesn't matter. But it's predominantly reactive. And we have to get to a point of proactivity, where not only are we able to answer questions when a user does log in, but we can tell them what they need to know before they knew it. And so this is the type of thing where we can actually anticipate their goals based on their data, based on our models running behind the scenes, and surface a notification that says something like, based on last year's yield data and spring soil moisture, 3 fields need a different hybrid. This is what transforms AI from being a chatbot to being a partner in the field. And so another thing that you'll hear from growers pretty frequently is, I don't have time for that. Or I don't have the wiggle room, because changing their plans once they set them at the beginning of the season is complicated. They've got to make sure that the product makes it all the way from the warehouse to the shed and into the tractor before they can apply it. And when you have things like a small, narrow planting window of 2 weeks, or replant time that can be even smaller, and combating this with weather conditions and other things, we have to make sure that we're changing the entire logistics framework of how agriculture works. We have to understand what somebody needs before they need it so that we can get it to them before they have to apply it. This is ultimately the only way that we can transform agriculture so that we're applying what the field needs right now. So with that, I'm gonna bring you back to the Minnesota retailer who said AI sounds like advice you'd get from a friend of a friend that knew that you had a farm. He's gonna be piloting CropWise AI this season. And it's not because he believes that this is gonna transform his work, and I don't know if we're gonna change his mind about this being personalized enough for him, but I know that we've earned the right to try. And the reason why is because we've tested this enough to understand that it's very likely that it's gonna survive contact with reality. So with that, I want to leave you a couple things that you can do today if you're planning to invest a lot of time and effort into Gen AI. And the first thing is, for researchers, start with the tests. Build your field readiness evaluation. Not just, how do I see through my system and test all the components, but how is a user going to expect this thing to work in real life? Go and talk with the grower. See if your research makes sense to them. See if it's something that they really want to have on their farm or they would use. This is how you start making sure that you're making early decisions that translate to a real product being used in the field. For people who are in industry, tighten that feedback loop. What we found was that the feedback that stings the most, that's where your signal is. The time that you want to put your head down on your desk, that's when you're getting critical advice that you need to make a change, and it's really going to truly outperform what you have today. And for those who are in extension, you're the pulse of the grower. This is our voice of the customer. You need to hold us accountable. Bring grad students out for a visit with the grower. Figure out how to actually take that advice and talk to growers and bring it back to academia and industry and say, you guys put this out, but it's not working. The feedback that I've gotten says that they actually wanted this instead of what you delivered. And I think if we can all start doing this, we'll find that a lot more of the work that we put into Gen AI and these AI capabilities will actually survive that test of reality. So my final words are try to test for reality, not the lab. And I know that this can be really difficult, especially with the early stage R&D projects where you're trying an unproven technology. But if you can start focusing on how this is going to translate into the field, all of a sudden you can start making a change. And so what I'm going to ask all of you to do is try to close the gap. With that, I'll take any questions.
Hello, thank you. It was really wonderful to hear your presentation. One of my questions is, what's the role that weather data and remote sensing data play in any of what you're developing? And are those sources of information of any value, or is your system built around other value sources?
Yeah, so that's a good question, and both of those are really important sources of information for us. So the way that we typically like to integrate with that data is don't give it directly to the large language model. Build a tool that will interpret satellite data or weather data and then hand back that interpreted information back to the large language model to share with the user. So a good example of that is we have a product called anomaly detection, right? What this is doing is it's looking at a field for multiple seasons. And then during the course of the season, if all of a sudden your NDVI values shift in a way that we believe, is not really normal, it's abnormal, or it's caused by stress, we would actually create an anomaly notification. Now that anomaly notification is what we would send back to the agent in order to talk to the user. With weather data, we might be integrating that for spray windows, right? When can I spray this product? So there are a number of different ways that we can integrate both satellite data and weather data, and it's not always a direct information feed. A lot of the time, it's through another tool or a model that we've developed.
Thank you for the presentation. That was a really compelling story, especially about how to fill the gap and benchmark and test against reality. My question is that adoption is really one variable in the equation, value is the other. As you go through this process, are you finding how much the farmer would value this after adoption? And where does that guide the business model? Is it an expected part of the product? Is it a premium part of the product? Like, how are you gauging the market?
Yeah, so that's a really good question. And one of the things that we try and do with a lot of these is take that product mindset, go prove value with something easy that doesn't take the full power of an engineering squad to build a capability and test it before you know that it's going to succeed. And so we frequently do this with prototypes where we go out to growers, we talk with them, we try to understand if we're hitting the mark or if we're totally missing, or if we're close and we need to make revisions until we really get it to the point where they need to see it. And that helps to, sort of hedge our bets considerably. So that we have faith that if we're going to put a ton of engineering effort into something, that we trust that growers will value it and use it. We do this all over the world, multiple times a year, different seasons, different products, and it really does make a difference in the final product that we end up delivering because we're actually talking to people up front. We're already starting to close that visibility gap before we've even started development. But great question.
Can you talk about your decision to use AWS Bedrock and maybe what are some limitations there with regard to large language models that are available on that platform?
Yeah, so what I can say is that when we started this project, Serge over here did a great job of analyzing AWS versus Microsoft versus, everything else that was out there. And it was a difficult decision. And at the end of the day, not all decisions are technical. Sometimes you go with what the rest of your platform is on. Sometimes you go with, who's willing to help fund development with you with their own experts. And so we definitely made decisions to start with AWS, and we have not transitioned away from AWS, but we are also integrating open source components too. It's not a one size fits all. And I don't think that there's a single AI provider out there right now that has complete coverage of everything that is truly needed in an AI infrastructure in order to completely close this gap. I think that all of them are getting closer. They're rushing towards it, but it's going to take some time before there's a true plug-and-play, one-stop shop for everything you need.
Thank you so much, Zach.